Let's look at differentiation graphically, because differentiation is really an issue of finding a rate of change. And you would see before in other notes that you may have read earlier that what you're really doing is finding a rate of change at an instant of time when it comes to differentiation. Now, suppose you have this graph, x to the power of 2. So that's x squared. Let's take a closer look. My topic here, okay, my topic can remain. All right, nice. Differentiation involves finding a rate of change, and it can be, you're looking at a rate of change at an instant of time instead of over an interval. All right, let's look at this graph. Y equals x squared, so it's x to the power of 2. Okay, we have y equals x squared. Now, one application of differentiation is to find the gradient of this graph at a particular point. Suppose we want to find the gradient of the graph at x equal 1. Well, one thing we could do is to draw a line somewhere which would be a chord. Draw a chord, no, not a chord, a tangent to the curve at x equals 1. It must touch the curve at x equal 1, but not cross it. Trying our best to do that. How do I make the tangent touch the curve? I want it to touch the curve. All right, let's say it touches the curve at x equal 1. Let me make my line thicker. All right, nice. So this is a tangent to the curve, and we can estimate the gradient of the curve based on the gradient of the tangent to the curve. We use a rise over run from a right angle triangle and do a rise over run calculation. But the thing is, what we have here is really just an estimate. Let me zoom out a bit. Yeah, we're just estimating the gradient. All right? Could extend the line a bit too. This is just an estimate of the gradient. The question is now, how do we find the exact gradient of the tangent, which is the exact gradient of the curve at x equal 1? All right. Suppose we do this. This is x equal 1. Suppose we have another point to consider. Let's consider a point at x equals 2. Let me extend this line. This is the point x equals 1, right? Right here is where we have x equals 1. We want to consider x equals 2, which is right at this point. If we should draw a line through that, then it would be, the gradient of it would be a little higher than the gradient at x equal 1. Let's see if we can make a line like that. Draw a line through these 2 points. Let's make the line a different color. What color would I want the line to be now? Maybe the line kind of greenish. And I want let's do it again. A darker green. Okay. And make the line very thick. Alright. So now what we have is a line where if we consider this point at 1 and this point is at 2, what is the gradient of this line? If this is 1, this would be 1 squared, which is 1, because it's x squared we're dealing with. This is 2, this would be 2 squared, which is 4. So the gradient of this line, let's say call it G, is the height, rise y2, which is 4, minus y1, which is 1, over x2, which is 2, minus x1, which is 1, because I'm considering this point, point 2, and this point, point 1. So y2, which is 4, minus y1, which is 1, over x2, which is 2, minus x1, which is 1. So the gradient is 3 over 1, alright, which is 3. Now, let us move point 2 closer to 1.5. So let point 2 be at 1.5 and the graph to be about here, right? Let's erase some of what I had. Alright, good. Point 2 is no longer here. And I want to kind of shift the line here. What is this thing here? Let me erase this point. Alright, so we have the line going through 1.5 and 1. And notice when the line went through 2, the gradient was higher, right? When it went through 2, 4. Now that we shift the point closer to 1, the point was here, it came down here, and we shifted closer. Notice the gradient isn't so high anymore. It seems as if the gradient of the green line, the gradient of this green line is getting a little nearer to the gradient of the black line which we used earlier to estimate. But what is the gradient of this green line? Let's see. The gradient of this green line. We have 1 and 1.5. So let's call this point 2 and this point 1. Point 1 is what? 1, 1, 1.5, 2.25. Alright, so 2.25 correspond with 1.5 and 1 correspond with 1. So right here we can find what rise over run. Alright, so what we have is the gradient is now equal to P2, Y2, which is 2.25 minus Y1, which is 1, over X2, which is 1.5 minus X1, which is 1. So 2.25 minus 1 is 1.25 over 1.5 minus 1, which is 0.5. 1.25 over 0.5. So what we have is 1.25 over 0.5, which is the same as 1.25 by 2. It's 0.625, right? So 2.25 minus 1 over 1.5 minus 1. So what we have is 1.2. Oh, wrong thing I did. 1.25 divided by 0.5. I should have. So it's 2.5. 2.5. All right. So it's 2. The gradient here is 2.5. What was it before? It was 4 minus 1 was 3. So it was 3 at first, and then it came to 2.5. Good. Now, let's do some erasing. And suppose we keep point 1 where it is, right at the point where we drew the original line. So we are at 1, 1. But instead of 1.5, let us move our point to x equal 1.3. So if we move to x equal 1.3 on the line, alright, 3 is 1.3 that I should have. We're moving x closer, and it's now at 1.3. When x is 1.3, what is y? Y is 1.3 squared, which is 1.69. So what we have is 1.3 let me draw it a little closer. 1.3 is about here, up to the line, not very straight, on the curve, and 1.69. Alright, so we locate x equal 1.3 here. We have a straight line. Well, this is not very straight, but it goes up to the curve, and then to the left we have 1.69 on the y-axis. 1.69. all right, so what we do, we shift the line so that it goes through 1 and 1.69. Make sure it goes through 1 and 1.69. And you notice the green line which we're shifting is lying closer and closer to the original line B. Now, let's see what the new gradient is. When we moved our green line closer, we had y2, which is 1.69 minus y1, which remains at 1, over x2, which is 1.3, minus x1, which is 1. So 1.69 minus 1 is equal to 0.69 divided by 1.3 minus 1 is 0.3. So what is 0.69 over 0.3? Let's see. 0.69 divided by 0.3 equals 2.3. So we get 2.3. So the next one was 2.3. The next gradient is 2.3. The thing is, we want to move the point very, very close. Suppose we move, first of all, let's maintain the 1. Suppose we move the point even closer to 1.1 instead of 1.3. Very, very close. This is now 1.1. At 1.1, when x is 1.1, x squared will be 1.1 squared, which is 1.21. So it would move over to 1.21. So this is our point 2, and our point 1 remain at 1, 1. So our point 1 is equal to 1, 1. Our point 2 is equal to 1.1, 1.21. What is the gradient here? It is y2. Remember, this is x2, y2, x1, y1. It is y2, which is 1.21 minus y1, which is 1.1 over x2, which is y2 minus y1. Oh, let me do that again. Y2, which is 1.21 minus y1, which is 1, over x2, which is 1.1 minus x1, which is 1. So 1.21 minus 1 is 0.21 divided by 1.1 minus 1 is equal to 0.1. But 0.21 over 0.1 is going to be 2.1. So the gradient is now 2.1. Alright. The thing is, we want to get even closer to that point. So we maintain our point 1 as 1, 1. 1, 1. But let's move very, 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 very close to 1. So we move at 1.001. Extremely close to 1. When x is 1.001, y is, you have 1.001 squared equals 1.002001. Let's write that down. So we're at 1.002001. Very, very close. So 0.2 is equal to 1.001, 1.002001. Let's see what the gradient is. But let's adjust our line. It would be extremely close to lying down on the black line. But let's see what it is. What is the gradient of that new line, or the green line now? It passes through 1, as well as 1.001, 1.002001. So the gradient is y2, which is 1.002001 minus y1, which is 1, over x2, which is 1.001 minus x1, which is 1. So this minus 1 is 0.00201 over this minus 1 is 0.001. Oh, suppose we multiply this by 1,000 and this by 1,000. What we have is 1, 2, 3, something over 1, 1, 2, 3, 2.001. So it's 2.001. It seems as if as we get closer and closer, as we move the point, right, on the curve, all the way from 2.4 to 1.5, 1.25, and we move it closer and closer to 1, we're going this way, the gradient of our green line approaches 2. So therefore, I can see that the limit as, let's call our point x. No, not x. Let us say that this was x plus a change in x, because x is right at 1. And then this addition to x was 2, then it got smaller to 1.5. So you had x right here, and then we had a small addition to x. Let's call it del x. This is referred to as del x. So this point would be 1 plus del x. And when x was 2, it was 1.1. When x was 1.5, which is 1 plus 0.5, give you the 1.5. When x was 1.1, it was the 1 plus 0.1, which gives you the 1.1. So, here, the limit of x plus, the limit of x plus that small change in x, right, approaches a certain value. Now we already have the x fixed, so we don't need to write x again. The delta x that you add to x, it was 1, then half, then 0.1, and it approaches 0. The limit of the gradient of x squared seems to be 2. I'm saying that as we add a value to x, in this case 1, it was 1 plus a small change, a number. It was 1 plus something added to 1. But in this case, since it's a graph, let's call it x. When x was 1, x plus a small change in x. We added something to x, and then we keep chopping that addition off, making it closer and closer to 0. So we were approaching 1. As that small addition tends to 0, the gradient seemed to approach 2, because when we had that tiny amount added to 1, it was 0.001 added to 1, the gradient was 2.001. So it seemed as if it was approaching 2. Alright, now that itself is really differentiation of this particular function, differentiation of x squared, where we find the exact gradient at x equal 1. Now it would be hard to go and find the gradient now at x equal 2, x equal 3, x equal 1.5, and so on and so forth. It would be a lot of work. Alright, so let's end this video now, and what we're going to do is look at a more general form of this gradient in a different video.